And this is my knapsack assignment. The problem is that we have a knapsack that holds up to 280 weight units, and we have six items with different weights and values. And the goal is just to maximize the value to be like the most efficient possible. So if we go to our main method down here, uh, so I set up the capacity as 280, right? That's what the weight is. We have our weight array, value array, and quantity array. Um, and I call both of the algorithms and then just print the result basically right here. Um, and then if we go to our dynamic programming, up over here, for each programming, I'm using a 2D table called DP. Each cell um, represents the best value we get, so just the most efficient route possible. And then I fill it row by row. If the item fits, I check whether taking it or leaving it gives a better value. And then I just check every step after that to find like the most efficient way possible. So a lot of rinse and repeat. Um, for the greedy method, um, I calculate the value to weight ratio for each item, sort them highest to lowest, and then I basically greedily grab the items in order. So if the item doesn't fit, I take a fraction of it and fill the remaining space. So that's why like the grading method gives a slightly higher number because it's solving like in a case where we could have fractions. Obviously, with whole items and whole numbers we can't, but in this situation we can. And then both methods are extended to handle quantities. The DP loops through how many of each item we could take, and the greedy just basically repeats and takes each item to its quantity limit. And then if I run it for us, we could see max value is 590 in part one and 650 again because we can't take fractions in this case. So that's why the greedy, that's why. And then the big takeaway with this one is just the DP is exact and optimal, but a lot slower versus the greedy is faster, but it's inconvenient when we can't use fractions. So in a real world, like when you can't split items, you would use dynamic programming, and then other than that, you would probably use a greedy technique.